All right. So, hello everyone. Very good evening to everyone. And we'll be discussing the Leetcode bi-weekly contest number 120 today. The date for today is 23rd of December. I'll be discussing all the problems from the contest which just took place around 2 hours ago. So, just for getting a better idea, I gave them contest myself today. It's been a long time since I came to contest. So, yeah, I did face some difficulties, but still I was still able to solve three problems within the time frame. Let's firstly see the contest. I still believe that the contest was such that anyone who was in a regular practice could have solved four questions, all of them straight away. So I was in not a very good practicing space, so I wasn't able to solve the fourth problem within the given time frame, but I got a bit late with a few minutes. But again, so it was an easy problem, and someone could have solved all four of them. So, well, let's probably just move on to the discussions for all these four problems. I'll be discussing each one of them one by one. I've solved all of them. So, I'll firstly discuss the approach, and then we'll be discussing the code for it. Okay. So let's start with the first problem. The easiest problem for this contest. We have been given a zero index integer array of positive integer nums. A sub-array of nums is called incremovable if nums becomes strictly increasing on removing the sub-array. For example, the sub-array 3, 4 is an incremovable sub-array of 5, 3, 4, 6, 7 because removing the sub-array changes the array to 5, 6, 7, which is strictly increasing. Return the total number of ink removable sub-arrays of nouns. Okay, this I will be pronouncing this ink removable. So yes, we need to identify all the sub-arrays which can be removed, and removing those sub-arrays will make the remaining sub-array as a strictly increasing array. This is what we need to find out. We need to find out how many such sub-arrays are existing within the given array, which has been given to us in the input. So the constraints for the problem are very less. We have a size of 50, so we can even take an n square approach for this. And this is what I'll be doing this for. Although we'll be having a difficult variation of this problem in the third problem, but I'll be firstly discussing the easy variation, how we'll be doing this. Okay. So let's firstly start. Okay. Problem one. All right. Okay. So let me just open the whiteboard now. All right. Okay. We have problem one. Okay. In this, what has been given to us is an array. Okay. We need to remove some subarrays from it such that removing a subarray every time, the remaining part of the array will be in a strictly increasing sorted order. Okay. Not sorted, not only sorted, it is strictly increasing as well. Increasing. Okay. We have strictly increasing subarray. Alright. Subarray, not the remaining array is a strictly increasing array. Okay. So what I can do is for the given constraints, I can simply just pick up the starting index. Okay. Let's say simply if I had to do this in an n square or a worse complexity. So what I can do is I can just simply pick up the I pointer. Okay. Uh, this will start from 0 and will go till n minus 1 every time. Okay. So this is the first index, okay, starting index of the subarray that I'm removing. That is what I'm assuming. And I'll run another nested loop, okay, for the j pointer. All right. So this will be the ending index of the subarray that I'm assuming that I'm removing. Okay. So if I'm removing the subarray from I to j, what are the elements that are left with me? I will do that in a different color. That will be from 0 till I minus 1 and j plus 1 till n minus 1. Okay. Alright. So the task boils down to whenever I remove elements from I to j is that I make a new vector. In C++, I can make a new vector. If it's Java, you can go for an array list. Okay. Array list if it's Java. Alright. So I'll make a vector or an array list and I'll push all these elements from 0 to I minus 1 and j plus 1 till n minus 1 in that vector, and I'll check whether that vector is sorted or not. Not just sorted, it should be strictly increasing as well. Okay, that means there should not be any repeating elements. Okay, all the elements are distinct and all of them are in strictly increasing order. Okay, that is what we need to check. So let's just move on to a new page and check a pseudo code for this first. Okay, so I'll start with a simple for loop. Take my I variable from 0. This goes till n minus 1. Okay, and I'll do I plus plus. All right, I'll take another nested loop for the j variable. This will go from I plus 1 because j is always greater than equal to I. Sorry, not greater than I. It can be equal to I as well because we can remove a single element as well, right? So we can have a subarrays of size 1 as well that we are removing. Okay, and I'll do j plus plus. Okay, so this is my nested for loop. Now what do I need to check? I create a vector. Okay, in C++, and I'm discussing the C++ specific solution. But the approach would be same in other languages as well. Okay, and I will need to push elements from 0 till I minus 1. Then I push elements from j plus 1 till n minus 1. Okay, this is what we are doing. All right, pushed all the elements. Now all I need to check is if this is sorted and increasing. Okay, sorted and increasing. Okay, that's it. If that's the case, then I'll maintain a global count variable here before the loops. I'll maintain a global count variable. Okay, and I'll increment the count. Okay, and I'll just need to return this count variable. Okay. All right. So this is how we are moving. Okay. We have discussed all the cases. Now let's see the time complexity for this. So this loop is running n times. Okay. This loop is also running n times. Okay. Then, well, this loop would be running, in the worst case, this will be n times only. And so is this. Okay. So we have 4 loops that are running in, but you see the structure is different. These two are the nested loops, n into n. And then we have this loop, which is nested. Then we have, sorry, I'll just erase this once. Yeah. Then we have these 2 loops, which are nested inside this, but if you see both of them, this push ones, okay, they have the same hierarchy level in our code. Okay, they are running in the same within these 2 nested loops only. Both of them are running this way only. So we have n into n plus n. Okay, so we have this worst case for this would be n in total, and for this is n square. N square into n. So the complexity would be n cube in this case. Okay, so this is our worst case complexity for this code. For this question, okay, let's just see the code for this one. All right. Okay, so I'm just declaring a count variable here. Okay, for count, returning the count, this is the size of the array. I run the first loop from 0 to n minus 1, the next loop from I till n. Okay, then I create a vector here. Inside the vector, I have two this thing, 2 loops for pushing elements. Okay, so I'm pushing all the elements from 0 till I minus 1. Okay, and then I'm pushing all the elements from j plus 1 till n minus 1. All right, so we are done. Now I just need to check if this size is greater than 0. Okay, because we do not want an empty array. Okay, this was mentioned in the question that the array that should be left should not be an empty one. All right, so we'll just check that if the size is greater than 0. And yeah, for checking if it is sorted, then it's a pretty easy case now. So simply I can just check this. Okay, r of I is greater than equal to I plus 1. Okay, this means that for 2 consecutive elements, the previous element should not be greater than or equal to the next element. Okay, this is how you'll be checking this. You can think about it. This is a very easy part. It's just checking a sorted array and checking if there are distinct values in that array. So Yeah. If this condition holds, that means this is not the required array. So we change the check variable to false and we break out of the loop and we just add this check value to the count. See, if this value is true, then 1 will get added. And if it is false at any point, then 0 will get added. So this is how we are doing this. And yeah, we'll just return count. So let's just try to submit this again. So this was accepted. Okay. This was the first problem. All right. Let's move on to the next problem. Okay. Find polygon with the larger parameter. This was an easy problem, but I made some mistake to it. So uh, it took me some time, but again, I compensated it for the third problem. So yeah. You're given an array of positive integer nums of length n. Polygon is a closed plane figure which has at least three sides. Okay. That means one polygon should have at least three sides. This simple mathematical term. Longest side of the polygon is smaller than the sum of the other sides. Okay. This is the condition for a polygon that the longest side, okay, uh, the value of the longest side should be less than the sum of all the other sides. Okay. This is the condition. All right. So this is what they have generalized it for a polygon of size greater than 3. That if you have k and k is greater than equal to 3 and you have positive real numbers, that means all the sides are real numbers, okay? Positive real numbers. Where this is again a sorted order for the sides. So what they're saying is that the sum of all the sides except for the greatest side, which is a of k, okay? Sum of all the sides should be greater than the last side, alright? So there, then in that case, there would always exist a polygon whose lengths have A1, A2, A3, AK. Okay, this is what they are asking. The perimeter of the polygon is the sum of lengths of its sides. It's a simple mathematical term again. So we just need to return the largest possible parameter of a polygon whose sides can be found from the given array, or -1 if it is impossible to create a polygon. Okay, so we need to return the largest parameter possible for any given polygon which can be created, and if no polygon can be created, then in that case we will just return -1. So if you just see this case, okay, we have been given the site. Okay, let's move on to the whiteboard quickly. Let's take a new page again. Excuse me. Okay, just a minute. Yeah. All right. So this is problem 2. Okay. In this, what we need to check, what is the condition of a polygon? That is sum of all sides is greater than sum of all sides except the greatest. Okay. Except the greatest. Okay. Is greater than the greatest side. Okay. Okay, this is what the condition says, and we have been given an array of elements. We just need to pick, okay, that what is the maximum possible parameter of the polygon. Okay, this is the only condition. So what we can do is think about it this way: that if you solve this array, all right, and for every element, if you check that is the sum of all the sides that come before it, okay, if they have a value which is greater than this side. Okay, if the sum of all the previous coming elements for every element is greater than this, the value of this side, then you have that as a possible answer. Okay, that means again I'll just repeat this. Okay, let's say I'm on an index I, so I need to check for all the values for an index I. How would I check if this can be the greatest side of my polygon? Okay, how will I check that? I'll just check if the sum of all these elements is greater than this, the side value of the ith side. Okay, this is what I need to check. And if this is the possible answer, then I'll take the sum of all these elements and I'll update it. Okay, with my perimeter variable. Okay, this is what I need to do. So I'll just maintain a perimeter variable, let's say. Okay, and every time if I encounter a case like this, which can be made as a polygon, so I'll just update this value. Okay, I just do this thing, max of perimeter, okay, comma, sum of 0 से लेके indexes till I. Alright. This is what we are doing. Okay. I just walk you through the pseudocode for it quickly. Okay. Alright. So yeah, this is what we are doing. So we just sort the array. Okay. Sort array or vector, whatever has been given to you. We sort it. Okay. Then what we do is that we just check for this is a single for loop question. Okay. I is equals to 0 till n. We'll go till n minus 1, sorry. Okay. And we'll check if we'll maintain a sum variable, let's say. You can maintain a prefix array for storing the previous sums, or you can maintain a sum variable as well. Okay. That's up to you. I was in the contest, so it was the prefix array. I don't know why it struck me first, and I went with the prefix array. So I'll just check that if array का ith element, if this value is, if the prefix for this, that is prefix of I minus 1, okay? If prefix of I minus 1 is greater, let's say I'm having a perimeter variable as well initialized to 0, okay? But if this is the case, then I'll update perimeter to max of perimeter, comma, prefix of I. I'm just adding it for short, okay? Plus prefix of I minus 1. Sorry, let me just drop this. I just remember this. Okay, so this will be a prefix of I minus 1 plus array of I. Okay, this is how we are doing this. Okay, so we just update this and we'll just return this. Okay, while returning, we'll check if perimeter is 0. Okay, that means we did not find any case. So I'll just return minus 1. Okay, I'll just return minus 1 in that case. Else, I'll return my perimeter. Okay. I would simply just return my p variable. Okay, this is how we are doing it. Also, what you can do is just to avoid this condition, just to shorten this a bit, you can initialize this by minus 1. Okay. So in that case, you will now not have to add this condition. P is equals to 0. You can straight away just return p. Okay, that is another possible optimization to this. Okay. Let's just see the code for this. So I was previously trying to do this by sliding window. I don't know why. But then it struck me that it is much easier as compared to that. So I just took the array size, sorted the array, created a prefix. Okay, this is the code for the prefix sum. All right, initialized my answer to minus 1, and I just checked for, because you see the minimum size is 3, so we cannot go from 0. We need to go from the index 2. Okay, so I'll just quickly correct this on the whiteboard as well. Okay, yeah, this will not be 0. Okay, this will be 2. Okay, because the minimum size, okay, keep that in mind that minimum size for polygon is 3. Okay, they have given in the question, and again that's a mathematical fact also. So for size 3 we start from index 2. I'll just check the prefix. Okay, I'll just check prefix of I here is storing the sum of all the elements till I. Okay, index I, so I need to check this is my total sum, if this is a possible perimeter. So I need to check if subtracting the ith element from it, and if this value x minus nums of I, if this is greater than the current element. Okay, this is my last element, this is the greatest element. Okay, keep that in mind. I was explaining it to you in a different way on the this thing whiteboard, but this happens to be the same approach altogether. The only difference is that here for a prefix of I, I'm storing all the elements till I. At that point in the on the whiteboard, I was storing all the elements till I minus 1 for prefix. Okay, I'm here storing all the elements till the index I. Okay, so for the index I, if this is the total sum, okay, so I need to check if the ith value can be the largest value of a polygon. So I'll subtract the value of nums of I from the total sum, that is x, that is prefix of I. So I'll just check that and I'll update my answer variable and I'll just return this. Okay. So this completes our code. Let's submit this again. Okay, this was accepted. Now let's quickly just discuss the time complexity for it. Okay. One of the students was asking me in the chat section that how do we decide the complexity? Okay, I'll just describe that after this point. Okay, so for sorting, the complexity is n log n for the inbuilt sort. Okay. This for loop declare having this for loop has n complexity. Okay. So this condition is again O of 1. So we are not having any complexity here. And return statement again has O of 1 complexity. So let's just make a tree that is all of them are in the same level. These are not nested. So n log n 1 1. Okay. So the maximum value of this is n log n. So the complexity for our code here would be n log n. Okay. The worst case complexity. How do you decide the complexity? See, if you see the constraints for this question, all right, it had been given to you that the value of n is 10 power 5. Just keep that in mind. Just keep that in mind once. Okay, that if you are having a value of array as 10 power 5, okay, so in that case, you can do a maximum of n log n or n. Okay, this is the maximum complexities you can reach. If you go for n squared, the value for just keep this value there 10 power 5 को n में रख दो. So this becomes 10 power 10. 10 power 10. What this signifies is the number of computations that the compiler would be doing. For all the compilers, the number of computations are somewhere between 10 power 8 to 10 power 9. Okay. So you should abide this limit. Whenever you do a complexity, just do a rough estimation of this, that whether your complexity is coming out to be less than this values. Okay. If it is anything greater than 10 power 8 or 10 power 9, then your code will of course throw a time limit exceeded error. Okay. So you should keep that in mind. Okay. While calculating the complexity, just take the maximum value of all the variables which are mentioned in the complexity and just see the calculated value, just the rough estimation of this is coming out to be less than 10 power 8 or 10 power 9. Okay. Although 10 power 7 is what I've seen कि जहाँ तक accept हो जाता है 10 power 7 or maybe close to 10 power 8. This is the point in which your code might get accepted. Okay. Again, this would depend a lot on the problem. So this you would learn by estimation only with time, practicing. Okay. So this is how you decide the complexity. So I had 10 power 5. If I go for n square, I'll have 10 power 10. So I cannot go for n square. Okay. If I go for n log n, this is again better than 10 power 8. This is less than 10 power 8. But do I have anything for n log n? Log n would mean a binary search. This is what I went with at the beginning. But binary search cannot be applied on this question. Okay. So if you just think about this, you will apply a greedy approach for O of n. Okay, for this is the usually this is the sorting complexity. So I'm not including this log n at the moment. I'm discussing about the core solution of it. Okay, core solution would mean the actual approach. If it would have been a sorted array, so what would you have done? Okay, n log n, of course you'll encounter because you are doing the sorting. But the core solution would have been a binary search, and binary search cannot be applied. So we just do a sorting and we then go for a greedy based solution for this. This is how we are doing it. Okay. So the complexity becomes O of n log n for sorting and n for the operations that we are doing. The crux of our code, like this solution. Okay, this part has O of n complexity. Okay, so n log n would be less than 10 powers 8, 10 power 9. So again, the code got accepted. Okay, so I hope this was clear to everyone. Still, if you have any questions, you can write down in the chat section. Okay, let's move on to the next problem. Okay, so this was an extension of the first problem, like where we had to remove the incremovable subarrays. Okay, the only difference was the constraints we were having. Okay, nums.length. Okay, the size of the array here is 10 power 5. In that first question, we had the size as 50. So that was a pretty easy one, but this is a complex one. I cannot go for an n cube solution here. Okay, let's move on to the whiteboard quickly. Okay. And we'll read the problem after this. Just give me a minute. Although the problem is not similar, it's the same problem as the first one. Only difference being the constraints. Okay. Problem 3. So this can be done in n cube. Okay, because we cannot have 10 power 5 का cube. Okay, 10 power 15. बहुत ज़्यादा हो जाएगा. So we will try to avoid that. Okay. How we'll do that? Let's firstly read the question. We need to remove the count the incremovable subarrays. Okay, this is what we need to do. Now, this is a bit of a complex problem from a contest perspective. Okay, I was able to solve it because I had a good practice with binary search. Okay, again, as I'm having, again, I've spoiled it now, but still, if I'm having 10 power 5, okay, but what are the possible solutions I can go for? That will be apart from sorting, leave sorting, because we'll have to, in this case, we are not doing any sorting. So no sorting can be applied to this. So what can be the possible solutions? N log n and O of n. Okay. This is the two possible complexities which seem to be most relevant with this. Some of you would argue, okay, sir, can't we go for n square root n? You can go for this, but do you see any cases for the square root? How would you add a code for the square root in this problem? It does not fit in the given scenario, okay? So it's probably going to be n log n or O of n. So now if you think about it a bit, okay, what I'm doing here is that, okay, I'll have to move to the whiteboard for this, okay? What I need to count, if this is my given array, okay, if this is my given array, I have some array size, okay, I need to count the subarrays in between, by removing which I'll get an array which will be completely sorted in an increasing order. So let's suppose I remove this subarray. So how do I not count it every time explicitly? What I can do is I can check whether my suffix and prefix, okay, if these are sorted. Think about this. Think about this carefully, that if you can maintain a value for this, till what point your prefix and suffix are sorted in the increasing order, then you can do a binary search. For example, if I just pick up my suffix, okay, I just pick up some suffix for an index I, that my array from I till n minus 1 is sorted. Okay, this is sorted increasing. Okay, I just now, if I know this point, then I can find using binary search, okay, how many subarrays I can remove from this. If I know this, I'll just do a binary search for all my prefixes and I'll check what is the maximum value of I from beginning which is sorted. Okay, and also I'll have to check. Let's name this as J, not I. Okay, this is I from starting and this is J. So if this is the maximum index which is sorted. So I just need to check if this is sorted, plus if nums of I is less than nums of J. Okay, why am I checking this condition? Think about this carefully. If I'm removing the subarray in between, okay, then I know that after combining, this should be one array which is sorted in increasing order. I have the value for this, that it is already increasing. I have the value for this, that this is also increasing. All I need to check whether these two elements are also strictly increasing or not. If that is the case, then I can simply add my answer. Okay. And what will be the answer in this case? Okay. Just think about this. Okay. If this is the case, then I'll know that all the subarrays, and let me just take a different color. Okay. If this and this is a valid pair, then I know all the pairs from I minus 1, I minus 2 till 0. This will also, all these will be the valid pairs with this element. Okay. Think about this. This is more of an observation based question. Okay. I'll just move on to a new page quickly. Wait a minute. Let's add a new page. Okay. Yeah. I'm not good with the writing part of it still. But chalo, anyways, I'll improve with time. Okay. So if this is I, this is J, this is n minus 1. Okay. If this is sort increasing, this is sorted increasing. So I know that if this holds the condition for these two elements, okay, then it is a possible answer. And how many possible answers do I have for this subarray? I also need to count that, because I cannot count explicitly every time. What is the purpose of binary search then? I'm doing binary search because I know if I can find an index that is a possible answer, then for all the indexes before this, that is I minus 1, I minus 2 till 0, these all will be the valid answers for this. Okay, think about this a bit. That again, if this is less than this, then of course I minus 1 will be less than this. I minus 2 also will be less than J. Okay. So those will also be the possible answers. So what you will do is we'll add the count variable. You'll do count plus equals to what will be the case? That will be how many sub-arrays you have counted now. That is I plus 1. Okay. I plus 1 sub-arrays. Okay. From 0 till I index. Okay. You have I plus 1 sub-arrays. Think about this. I minus 1, I minus 2. Let's suppose I is 3. Okay. So from 0 till index 3, how many sub-arrays we are adding? 0, 0, 1, 0, 2. 0, 3. That is 4 in total. That is I plus 1. 3 plus 1, 4. Okay. This is what we are doing. Now this is one count. Okay. Now what I need to count two things as well. Apart from this is for the sub-arrays that I'm removing. Okay. From the between part of it. Now let's suppose I'm removing some sub-arrays from the starting and some of it from the end. Okay. Let's suppose I'm removing some. If I'm removing sub-arrays from the starting, okay, like this is the complete array. At every step, I'll remove till this point, then till this point, then till this point, then till this point. So I need to check whether this complete part is sorted or not on every case. Okay. I had already maintained a count for this using a prefix and suffix subarray. Okay. So this would again be the same case. All right. So I can just simply increment my count every time. And similarly for this case, like if I need to remove subarrays completely from the end, if I'm removing the subarrays like this, okay. So at every step I need to check if this value is a sorted array or not. If this is sorted, okay. If this is sorted, then you can have it, okay. You can increment your count. So you would have maintained a prefix for this as well, just to save your time, okay. So this is how we are going for it. And yeah, we'll just return the count at the end, okay. Now let's firstly move on to the code for this. Then we'll discuss how this is working, okay. I'd like to explain this using the code only because this was a difficult problem. All right. Took me some time, but again, for me, I had done similar problems. So for me, it was an easy one. Okay. So I've added some base cases. That if n is equals to 1, you'll return 1. If n is equals to 2, you return 3. You can count this. Okay. Now let's move on to the case when I'm storing for my suffixes, whether they are sorted or not. Okay. I'm storing for my suffixes if sorted, increasing order. Okay, this is what I'm checking. So well, if I'm taking only the last element as my subarray, so of course that is sorted. Then if I go for a previous element, I'll just check if the next element is sorted or not. Okay, if dp of I plus 1 was sorted or not. So I'll add this and I'll check if the next element is strictly greater than the current element. So I'll set the ith dp value to true. This means that elements from I till n minus 1 are sorted, okay, increasing order, okay. Similarly, I'll have this thing for the prefix as well, okay. So for the prefix also, I'm checking the same case. For the prefix, I'll have to compare it with the previous element, okay. I'm checking at this point, I'm checking all the elements from 0 till I are sorted in increasing order, okay. This is what I'm checking. Okay. Also for the else condition, if dp of I plus 1 is false. Okay. Let's suppose at some point, let's move on to the whiteboard. Okay. So let's say at some point, if I say that this sum index k, okay, this subarray is not sorted. Okay. This is not sorted. So of course I know that j till n minus 1, this will also not be sorted then. Okay. This is pretty obvious because k till n minus 1 is also a part of j till n minus 1. So if this smaller part is not sorted, then the larger part will also be not sorted as they have asked, right? This is what we are maintaining here. Okay. So we have these two values. Okay. Now I'll just add a loop here. Okay. I'll just pick up my last index that as I told you on the whiteboard as well, that what I was doing is I was picking up this value. Do a different color. I was picking up this j value every time, and I'm doing a binary search on the starting prefix part of it. Okay. So I'm just fix this and do a binary search on this part. This is what we are doing. Okay. So I'll just fix to this. Okay. If this is true, only then we can check. If it is false, then we break. Simple as that. So I'll fix this part and I'll do a binary search from 0 till I minus 2. Why I'm doing I minus 2, why I'm not doing I minus 1? See, if this is the case that I till n minus 1, okay, n minus 1, and you are having the elements like this, okay, I minus 2, I minus 1. So you will of course remove at least a single element if you are removing a subarray. If I do I minus 1 here, that would mean that we are also considering the cases in which we are not removing any subarray. So why would we want to take that case? Okay, we are at least removing one subarray with at least one element. No? We are not taking empty subarrays here. Okay, so that is why I'm going for I minus 2. I initialize my answer variable to be minus 1. This is the index. Okay, this is the index from the beginning for which 0 till answer is the index. So this value are sorted. Okay, sorted increasingly. Okay, don't forget that in this question sorting would mean sorted in an increasing order as well. Okay, so sorted in an increasing order, I just check, I just compare it every time. If I'll just take a middle element, like this is the last element, and I'll check it with my ith element. If that is less than that, then this is a possible answer, and I'll update my value for start to m plus 1 and end value, end pointer to m minus 1. Okay, I will this part you can remove. This is just for my checking. Okay. Now if answer is not equals to minus 1, so you will add answer plus 1 or subarrays. Again, I have mentioned that as well, that this would be answer plus 1 subarrays, I plus 1. Okay. So this is what I had mentioned. All right. And I'm just quickly iterating through it. So this is the subarrays. Now let's move on to the second and third part. Okay. Second and third part, from the ending and from the beginning, I'm checking if the array is sorted, so I'll increase the count every time. Okay, this is what we are doing. Now only one case is left. Okay, here this was what I did in contest just to incorporate some base cases, that if your array is already strictly sorted, okay, like if the array is something like this 1 2 3 4, which is already strictly increasing and it has distinct elements, all of them, okay, so at this point you would have counted it twice, okay, because you are checking from all the subarrays from n minus 1 till 0. So you would have taken at 0 point, you would have incremented it, and at this point as well you would have incremented it. So you would have taken it 2 extra times, and we are already starting our count from 1 because we want to have the empty array. Okay, that is the case when we are taking the complete subarray. Okay, so this is the one possible case only for the empty subarray. We cannot have more than one empty subarray, so I've incorporated it at the beginning because this would be present in our count every time. Okay. So yeah, if this condition holds true, that it is a already sorted increasing order array. So if this condition holds true, then I will have to do count minus equals to 2. Just to remove these 2 extra pieces I've counted here, and I'll simply just return my count variable. I know that this is a bit confusing, but you can rewatch the video, rewind it, and then uh, understand this. And still, if you have any queries, we can discuss it in the chat section. Okay, I'll just submit this for now. Okay. Yeah. All right. So this is how we are doing. So the first 3 problems are based on the array-based questions only. So again, those were easy problems for Leetcode contest. You can expect any questions like this in your interviews or in your OS for any company. Okay. So we'll just move on to the last problem now. So this was an easy problem, but a good problem. Okay. The only problem for this question was that the code was too long. So I wasn't able to code it with that speed and the given time. So that was the only problem. Okay. Let's read the question. You have a given undirected tree with n nodes labeled from 0 to n minus 1 and rooted at 0. You're given a 2D array edges. Okay, we have been given an undirected tree. We have edges, bidirectional edges. Okay. You're given a 0 index array cost, which is the cost of the ith node. Okay. You need to place some coins on every node of the tree. The number of coins to be placed at node I can be calculated as this. Okay. So we need to place some coins on every node. And how many coins we need to place on every node? These 2 conditions govern that. If the size of the subtree of node I is less than 3, then you will place 1 coin, whatever the case may be. Okay. If the size of the subtree for the ith node is less than 3. Okay. Otherwise, you need to place amount of coins equal to the maximum product of the cost values assigned to three distinct nodes in the subtree of node I. This is difficult. This is difficult to understand. I'll reiterate this. That let's say I have a node I and I have its subtree. So if the size of that subtree is greater than 3, and I would have assigned some coins to each node in the subtree, no? So I'll just take the maximum values of these, maximum 3 values of this, and I'll just take the product of that and I'll place that many coins at the ith node. This is what I need to do. Okay. So, and I need to return an array coin of size n that such that coin I is the number of coins I commit number of coins placed at the node I. Okay. This is what they are asking. So we are going from 0 to n minus 1, all the nodes. We have edges, we have the cost array. So we need to return the array with the points placed, which specifies the number of points placed at each node. Okay. Now let's just move on to the whiteboard. It's a bit difficult. If you are new to coding, I wouldn't recommend you wouldn't simply understand this, but this is more of an expert kind of a question. Okay, you need some additional DFS knowledge, okay, for this. The approach we'll follow for this is DFS. Okay, firstly specifying that. Okay, problem 4. Okay, so we have a tree. Okay, let's say I have this is a bidirectional tree. Okay, okay, this is what we are having. Let's see. Okay, so for every node, I need to check if let's take 2 more nodes here. This is the subtree I'm having. So for let's say if I'm taking this node, understand this. Listen to me carefully on this. Okay, if I'm taking this node, okay, size of the subarray of this is 5. Okay, one root node itself 1, 2, 3, 4, 5. Okay, let's say I'm placing some points here: X, Y, Z, W. Okay, E. Alright. I just need to see this the cost value for this node. Okay, so I'll consider this as a. I need to check what is the maximum product for all for 3 values from this. I can take any 3 values, okay, but I just need to place the maximum product of all those 3 values at this node. Okay, so how do I take the maximum product? Okay, if I have 3 elements A, B, C, all right, these can be less than 0 as well. So what can be the maximum product I can have from all these values? Think about this, that let's say I have 100 values in total. So 100 values, what I can do is simply what everyone would say, sir, we can sort this thing, okay, and we can have the last 3 values. Okay, this is absolutely correct. This can be a possible answer, but then there can be another possible case, that is if we sort this, okay, and I can take, if I have negative values here, okay, assuming, so I can take the first 2 values, okay, first 2 values, which will be the most negative values, okay, and I'll multiply them with the last value, okay. So this can be also a possible answer. So we have these 2 possible cases for the maximum answer for every node, okay. If the size is greater than 3, this and this, I just need to take the maximum of this, okay. I just take the maximum of these 2 values if size is greater than 3. If less than 3, then of course we do not have any case, we'll just place 1 coin at that point. Okay. Now how do we do the movement in the tree? Okay. We'll do a DFS here. Okay. Let me just make a clean tree here. All right. Okay. 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 So let's say if I'm taking this node only. Okay. So I firstly have the answer for this one, that is 1, 1, 1. Okay. Now for this node, the answer will again be 1. For these 2, this is the size equal to 3, not greater than 3. So for this as well, the answer would be 1. Okay. Now I'll check the answer for this node. Okay. What will that be? Because all the nodes here are less than 3. So in this case, the answer will be 1. But what would have been the case if I had this? Okay, let's say I have something like this here. Okay, 1, 1, 1, 1. Think about this a bit. That we'll have to take this, the cost of this. Okay, and the maximum value from this probably, or the three values. Okay, and some values from here. Let me just explain this properly. Just give me a minute. I think I just fumbled that a bit. Okay, you just, yes, or let's wrap this complete and let's have a clean slate. We'll start from the beginning. No problems. This is something which is more of an observation, imagination based question. Okay. So let's take an example from the given examples only. Why are we wasting our time on this? Okay. 1, 2, 3, 1, 2, 3. Okay. Let's move on to the why. Alright. So yeah. Okay. Okay. So answer for all of them would be 1, 1, 1, 1, 1, 1. Okay. What would be the answer for this node? Think about this a bit. Okay. That will be the maximum. That will be uh, the maximum of three values for this. What values we have here? That is this value. Okay. We are having this. All right. And we are having the cost of these nodes as well. Okay. So we have these four values X, Y, Z, W. So let's suppose this is how we are going X, Y, Z, W. Okay. So either I'll take the last three ones or I'll take the first two or this one. Okay. And if in every case, think about this. What do you need to maintain for every node? When you will run DFS from these nodes, okay, what you should return. Okay. This is what I'm trying to signify, that you just need, if the number of values are greater than, let's say, 3. Okay. So what do you need to return? You need to return the small 3 and the largest 3. Okay, this is all what you need to return in this case. Smallest 3 and the largest 3. That is all you need. Because from the largest 3, you can just take the product, or you can take the first 2 from the smallest and you can take the largest from this. Okay. This is all you need for every element. And you can just calculate the answer. That will be a simple, this thing. So that will be a simple multiplication and maximum case, okay? You can just do a comparison between those two values, whichever is greater, you can place. If the size is greater than 3. If size is less than 3, of course, we are just having 1. Simple as that, okay? And we are doing the number of operations that we are doing is n only, okay? For every node, what we are doing, the worst case would be n log n, okay? Because we are just iterating over all the nodes, okay? We are iterating over all the nodes n, and we are maintaining a set or a priority queue data structure for maintaining the lowest 3 and the largest 3. Okay. So we are having log n complexity for that for every case. So I'll just somewhat say this as n log n. Okay. Let's move on to the desktop. I'll just quickly show the code for it. These kind of questions are the cases where you need to have some understanding on your end as well. Then only you'll be able to understand this. Okay. This is not meant for beginners. As I said, this is a hard problem. So, yeah. So firstly, I'm taking my map. Okay. I'm just preparing my graph. So I hope everyone knows how to prepare a graph by directional edges. Okay. I'm just preparing a graph and I'm calling my DFS. Okay. Now this is very important. What I'm having the return type for my DFS is a pair of multiset, multiset. You can have priority queue, priority queue as well. Okay. Why we are doing this data structure? Because at every step we need to maintain the largest three and smallest 3 values. Okay. If the size is greater than 3, if it is less than 3, then you can maintain the smallest 2 or the largest 2, smallest 1 or the largest 1. That's up to you. Okay. So that is the case we are handling it. Okay, let's just, this was a bad condition I had added. Okay. Yeah, how we are doing this? Also, I'll need to maintain, because this is a bidirectional one. So if we are calling a DFS on this, you'll have to maintain a visited array as well. So if a node is visited, you do not visit that array. Okay. So I'll mark my source node. I'm starting from 0 only, because we have mentioned that the root node is 0. Okay. So you start from 0. Okay, you mark this as visited. You take two multisets, upper and lower. Okay, upper would be the large 3 large 3 values, and lower one would be the small 3 values. Okay, this is what we are doing. You push this to the array. Okay, sorry, not array, multi-set. You'll have to push the current source value as well. Okay, because this also comes in your subtree, right? So you need to push the value for this source node as well. So pushing the cost of source node as well. Then I'm iterating over all my neighbors. I check if my neighbor is not visited. If it is visited, why would I go over it again? So I just take the neighbors which are not visited. So I'll go over that and I'll call DFS on them. What we are returning from that neighbor? Again, pair of multiset. Okay. This is the lower one and this is the higher one. Okay. Now I'll just iterate over the lower one firstly and I'll insert it in my this lower multiset for this source node. Okay. If the size at any point is greater than 3, because I need to maintain only 3 values. Why am I only maintaining 3 values? Just to save my complexity. If we have values greater than 3, then let's suppose we have the tree for 10,000 nodes. So we will be having some very large multisets and we'll be incorporating a lot of complexity. And why would we need 1,000 values? We only need the 3 starting values, right? So if the size for the smaller 3 nodes, for the multiset which is maintaining the smallest 3 values, if the size for that is greater than 3, which node should I remove? Multiset sorts the value in increasing order and I need the smallest 3 values. So of course I'll remove the last value. So I just remove the last element here. Okay. I'm just removing the last one. Similarly for this case, for the larger one, where we are maintaining the largest 3 values, I'll insert it to my this one multiset by the name U. That is the upper one. Okay. If the size is greater than 3, for maintaining the greater 3 values, what will we do? We'll remove the lowest value, and the lowest value is at the beginning. So I'll remove the beginning value. Okay. Beginning slash first value. So I just remove that if the size is greater than 3 again. Okay. And when I'll come out of all this, I'll iterate over all the neighbors. So I'll have the largest 3 and the smallest 3 values from our complete subtree. Okay. The U and L will store the lowest 3 and the largest 3 for the complete subtree. Okay. Including this node as well. It will include the lowest 3 and the largest 3 costs for all the nodes. Alright. Keep that in mind. Now, if the size of U is less than 3, of course, if the size of U is less than 3, then of course the size of L will also be less than 3. Keep that in mind that U and L will have same size, okay? They'll have same size every time. So we'll mark the answer as 1, as I said, because it has been given in the question. Alright? We have the answer array here, vector here, which is declared globally. So I'll just add the source node coming from this DFS function. I'll mark the value as 1. Okay. Now to have the second case, for this case, this one, just let me take the marker in. Okay, in this case we were having XYZW, the first 2 and the last one or the last 3. Okay. What will I do? Firstly, let's take the last 3. Okay. So I have my iterator pointed to the end. I have taken the last value, greatest, second greatest, and third greatest. This is all a C++ specific syntax. So if some of you are unaware of this syntax, you can refer a Java solution. The approach would remain same. Just the syntax would change. Okay. And this is the smallest one from the low set, multi-set, sorry. So smallest, and second smallest, okay. And I'll just take the maximum of these two. Maximum of x, y, z, that is the greatest 3, or the smallest 2, and the largest one, that is x, okay. I just do that. And also we have been given, if it is not possible to have a value greater than 0, read this condition. If the product is negative, place 0 points, okay? Place 0 points if the product is negative, right? So if the product would have been negative, I'll just check it. I just take the maximum value of answer, comma 0. If it would have been negative, it will automatically get updated to 0, right? And what do I return from this? This is very important now. What are we returning from every DFS? We are returning a pair of multiset, right? So this is what I've returned from this one as well. And what will be those multi-sets? That will be U and N for the current node. Okay, for the source node, that will be the cases, right? So I just return L comma U as the pair. Okay, and that is all. So I'll just call the DFS here, and the answer vector will get updated for sure, and we'll just return the answer vector. Now let's try to run our code on a sample case first. Okay, it's taking some time. It's finished. Okay, let's wait for some time. It's accepted, right? It took some time to accept, but yeah, we are getting the accepted. The complexity, as I said, we are doing n operations for iterating over all the nodes, and we were doing some log n operations. So I would take that as log n. So it would be somewhat close to n log n. That will be the complexity for this code. Okay. And yes, so this is the discussion for our session. I just would like to highlight a few points, just a complete analysis of this. Okay. So if you're having a decent practice, if you are good with your preparation, then problem one was a very, very easy problem. This could have been done. Problem two was again a very easy problem. Problem three, okay. This was somewhat is it was a if you're good with binary search or something, then it could have been solved or not. I'll rate this. This was easy. This was easy. This was medium. Okay. Someone who's having a very good preparation, he could have surely done that. And problem four, this was somewhere between medium to difficult, but more on the medium side. Okay. So yeah, this again, someone who's having a very good preparation, good with the data structures, all the tree problems, so he could have done this easily. Okay. So we had these four problems, and yeah, that's all. The total time for this contest would have been maybe 5 minutes for this one, 10 minutes for this one, max, and again 15 for this, and let's say 15, somewhere around 20 to 25 for this question because the code was very long. Okay, so yeah, this was the total time span of this contest. If you are having good preparation and if you are in the zone of solving regular 5-10 questions every day. Okay, so I hope you had a good session and we'll be meeting in the next session. Till that time, happy learning. Have a nice day. Good night, everyone. Bye bye. So, yeah, let's just end this one.